Hello and welcome back to another video. Here we are going to discuss the next three questions from October-November 2020 970912, that is pure mathematics 1, and here is the question number 6.
A part, prove the identity 1 over cos x minus tan x into 1 over sin x plus 1 is equivalent to 1 upon tan x. So we'll start in this type of question from the one side, that is, let's say left hand side in this case. So it can be written as 1 upon cos x minus sin upon cos, because in AS level we have only two identities. One is sin x, tan x is equal to sin x upon cos x, and another is sin square x plus cos square x is equal to 1. And this one we can write 1 plus sin x upon sin x. And now we will take this denominator cos x and numerator become 1 minus sin x, and here it is 1 plus sin x upon sin x. So numerator become a minus b into a plus b, so that is a square minus b square, 1 minus sin square x upon sin x into cos x. And now we can write it as cos square x, because another identity 1 minus sin square x is cos square x upon sin x into cos x. So 1 power is gone. It can be written as 1 over sin x upon cos x. I bring this cos x in denominator, so it becomes like that, and it is equivalent to 1 over tan x, which is the right hand side, and hence proved. So let's do the B part of this question. Here's the B part. Hence solve this is equal to 2 tan square x in 0 to 180. So from the first part we have seen that it is equivalent to 1 upon tan x, so we'll write it as 1 upon tan x is equal to 2 times tan square x, and hence we can transfer it and we will get 2 tangent cube x is equal to 1, or tan x as cube root of 1 upon 2, and we'll get from here the x value as tan inverse of cube root of 1 upon 2. We could have written the simplified form, but that's fine. Cube root of tangent inverse of cube root of 1 over 2, and this value is coming 38 degree, 38.439 degree, and so on. And for the next angle we can calculate as 180 plus, but that would be more than 180. So the solution is going to be x is equal to 38.4 degree only. No other angle would be possible. Here's the question number 7. The point 47 lies on the curve y is equal to fx, and it is given that f dash x is equal to this. A point moves along the curve in such a way that x coordinate is increasing at a constant rate 0.12 units per second. Find the rate of increase of y coordinate when x is equal to 4. So this is given the rate of change in x, so dx over dt is provided. We need to find rate of increase in this, means we need to find dy over dt when x is equal to 4. So what we are going to do, first of all we'll find what is f dash x. F dash x we can write it as dy over dx if we take y, and this is given as 6x to the power minus half minus 4x to the power minus 3 by 2 here, and we require dy over dt, means we can find dy over dx here and then dx over dt, chain rule. So dy over dx at x is equal to 4, it is going to be 6 upon square root of 4 minus 4 upon cube of square root of 4 multiply by dx upon dt, which is 0.12. So we'll simplify it. It is going to be 2, so 3 and it is going to be 4 upon 8, so 1 upon 2. So 3 minus 1 upon 2 into 0.12, and 3 minus 1 upon 2 is 2.5. 3 to just 6 minus 1 5. 5 by 2 into 0.12, it is 0.06, and 6 5s are 30, so it is 0.3. So rate of increase of y coordinate when x is equal to 4 is 0.3 units per second. Now B part, find the equation of curve. So since f dash x was given as 6x to the power minus half minus 4x to the power minus 3 by 2. So equation of curve would be fx is going to be integration of this. So integration of this from 6x to the power minus 1 by 2 dx minus 4 times again integration of x to the power minus 3 by 2 dx. So it is 6x to the power minus 1 by 2 plus 1 is 1 by 2. Divide by 1 by 2 minus 4 times x to the power minus 3 by 2 plus 1 is x to the power 1 minus 1 by 2, x to the power minus 1 by 2 upon minus 1 by 2 and plus constant of integration f of x. So we'll solve it. It is 3x to the power 1 by 2 plus 4 2s are 8. Sorry, it is 6 2s are 12, and here 8 x to the power minus 1 by 2 plus constant of integration. Now we have seen that when x we had one value, it is given that 4 7 lies on the graph, so it is going to be 7 when x is equal to 4. So 12 into root 4 is 2 plus 8 into root 4 minus root 4 is going to be 1 upon 2 plus c, 2 4s are, and we got it from here as c is equal to 7 minus 24 minus 4, so minus 28, it is minus 21. So fx is 12x to the power 1 by 2 plus 8 over x to the power 1 by 2 minus 21. So that is the equation of curve. So that's it. Let's do the next question. Here's the question number 8. In the diagram, ABC is an isosceles triangle with AB is equal to BC is equal to r centimeter, and angle BAC is theta radian. The point D lies on AC, and ABD is sector of a circle with center A. Express the area of shaded region in terms of r and theta. So first of all we will calculate the area of triangle ABC, and since AB is equal to BC, this implies angle BCA is also theta radian. So area of triangle ABC we can get by the sine rule, 1 upon 2 times r into r, and then angle between them, that is this, and it is going to be sine of pi minus 2 theta. Pi minus 2 theta, because theta and this angle is going to be pi minus 2 theta. And area of, we can write also, this is going to be sine theta, same as sine theta, so it is 1 upon 2 r square sine 2 theta, because we know that sine pi minus theta is theta, sine theta. And area of sector is going to be half r square theta, so half r square, and the angle is theta. So required area required area is going to be area of triangle half r square sine 2 theta minus area of sector half r square theta. So that is the answer. We can take r square upon 2 common, and it is sine 2 theta minus theta. That is the required area in terms of r and theta. I hope it is clear. Let's do the second part. Here's the B part of 8th. In the case where r is equal to 10 and theta is equal to 0.6, find the perimeter of the shaded region. So we are going to find the perimeter of the shaded region, and I have already copied the diagram here. So we need to find this length, because this length is already given r, and we need to find the arc length for the perimeter. So first of all, we'll calculate AC, and we can subtract AD because AD is already R because it's a radius, and AC we can calculate by with the help of sine rule. This angle is pi minus 2 theta. So sine pi minus 2 theta upon AC is equal to sine theta upon r, these two, and hence AC is going to be r, I cross multiplied r sine, and pi minus 2 theta is sine 2 theta, so sine 2 theta upon sine theta. We'll simplify and then we'll put the value of r and theta. It is going to be r2 sine theta cos theta over sine theta. These two got cancelled. So AC, so DC, which part we require, DC is going to be AC minus AD, that is 2r cos theta. So 2 times r 10, 20 cos 0.6 minus r, that is 10, and arc length is equal to r theta. So r theta would be 10 into 0.6, so 6 here. So this perimeter of the shaded region PL, right? P is going to be B to BC, and then DC, and then arc BD, which is going to be R plus DC is this 20. I'll write r in place of r. I'll write 10 now because we know that it is 10 plus DC is 20 cos 0.6 minus 10 plus 6. So we can see these two got cancelled, and we can also calculate the value of cos 0.6. It is going to be 0.825 and all, so multiplied by 20, it is going to be 16.5067 and all, plus 6 will be 22.506, so I'll write 22.5 only. So this is the perimeter, so it is centimeter. So that's it for this video. We'll discuss the last few questions in the next video. Till then, thank you so much.